My name is EM2 and my claim is on average, most college students get 6 to 6.9 hours of sleep per night. The null hypothesis means there is no difference between the true average sleep and the claimed value. I took the average of 6 to 6.9, which I got 6.45 for my null hypothesis. For my alternative hypothesis, I was interested in whether it is greater or less than the hypothesized mean, which means it is a two-tailed test. For my sample data, I collected the data from 31 students, and the sample can be used because it is collected from college students and it is relevant to my claim itself. Is my working, my sample size 31, hypothesized mean is 6.45. For my sample mean, I calculated the average from student 1 to all the way to student 31. Next is sample standard deviation, which measures how far the data points are spread out from the true mean. I calculated it using this formula all the way from student 1 to student 31. I got a value of 0.24, which is low, which means that data are not widely spread out. My test statistic, I used t-test instead of c-test because my population standard deviation was unknown. Due to central limit theorem, if the sample size is greater than the t, we can use the t-test. Next is the p-value. The p-value tells us how likely it is that results we see in our data happen by chance. I calculated the p-value using this formula. This is my test statistic, and this is my n minus 1, and I multiplied it with 2 because it is a two-tailed test, and I got this value. This is my degree of freedom, which is n minus 1. The significance level means the threshold we set to decide whether our results are strong enough to reject the null hypothesis, which means I'm taking 5% chance of wrongly rejecting the null hypothesis. To my observation, my p-value is greater than significance level, which we can conclude that there is insufficient evidence that the true means differs from 6.45. The confidence interval, we minus our significance level from 1, which we got 0.95. Margin of error means how much we can expect samples result to vary from true population result. I calculated my margin of error using confidence T, significance level, sample standard deviation, and sample size. Now we can construct our confidence interval, and the formula for it is sample mean plus or minus margin of error. And as we calculated, the value was within the range of 6.44 to 6.62. And we are 95% confident about it. This is the end of my video. Thank you for watching.